Okay, please take 577. Right. I can throw. Okay. Now, so if you take Python exam, there are total 10 code books. So we already completed 7. So last week completed 6. Today morning the 7th one. These are called major code books. Then next 3 is left out. These are called common code books. Why they are called common code books? It is applicable for all AP exams. In future, if you attend 570 or 653, these 3 code books are common. That's why these are called code books, the common code books. Now, 577, section 5, section 9, these 3 books, this together will have around 20 questions, all the 3 together. If you already have a welding or NDT, you got it? Okay. Already have a welding or NDT knowledge, this question will be simple. And most of the people, sometimes they are struggling in the WPS speaker interpretation, section 9. That's why generally we used to do section 9 last day. But there was a feedback from students, no sir, we don't have time to ask doubts. So we changed that one. So today I will start 577 metallurgy, just to come as a preliminary metallurgy. Okay, it is not a very detailed metallurgy class. Okay, simple metallurgy only we are going to do this. Metallurgy and mechanical testing, then welding process, then we will do tomorrow section 9. So because all of you have NDT knowledge, I think everybody have NDT knowledge. NDT will be the last day, Wednesday. Thursday we will go for a review. Okay. Now, if you take 577, it's a 3-part. Welding process 1 part, inspection means NDT, and metallurgy is the 3rd part. Now let us start with the metallurgy. The same question only. What is steel? What is steel? Alloy of iron and carbon. Okay. Now the next question, how the steel is manufactured? Steel can be manufactured in 2 ways. One is casting, another one is wrought. Wrought products or cast products. See, okay. So wrought or cast. Okay. And another one is cast. Now, what is the difference between wrought products and cast products? The major difference between wrought product and cast product is during the melting, if you are getting the final shape, that is called cast. If there is no relation between the final shape and the molten shape, they are called as a wrought products. For example, wall bodies. If you take wall, what they will do first, they will make a pattern. From the pattern, they will make a mold. From the mold, they will pour a steel, then they will get a final shape. That is called casting. Whereas wrought product, the process is they will make a ingot, like a box type. Then it will go subsequent primary processing. What are the primary processing? Rolling, forging, welding, extrusion. Now, one exam question is, which of the following primary process is akin? Akin means similar to casting. Out of this 4 primary processing, rolling, forging, welding, extrusion, which one is similar to casting? What is your answer? Forging. Any other answer? Extrusion. So only 2 left out. One is rolling, another one is welding. So the correct answer is welding. Why? What is the common thing between casting and welding is only in these two processes the material is melted. If we take a rolling, forging, extrusion, all are done in the solid state. Whereas welding, we are melting the electrode as well as base metal. Casting also, we are melting it. So this is one of the examples. I am going to just a key points for you. Now, when you receive the material, it will come with a material test certificates. Again, there are two types of material test certificates. Cast analysis, sometimes it is called as a ladle analysis. Another one is called product analysis. Cast analysis means during the ingot, they will take sample and test it. Product analysis means final product like a pipe, plate, all these things. They will check. Which one is important for the inspector? Cast analysis or product analysis? Product analysis, final product. Now the next question, casting and another one is called wrought products. Which are the following product most widely used in the industry? Wrought. This out of these two, which are mostly used in the oil and gas industry? Wrought products. Plate, pipes, all are wrought products, except wall bodies. So casting generally will have around 10%. 90% of product what we are using is a wrought product. Simple question and answer session only this one. The next one, if you take material, it will have three types of properties. Physical properties, chemical properties, mechanical properties. Now, what are the physical properties? What is the difference between physical, chemical, and mechanical properties? Physical properties cannot be changed by force. Chemical properties mean basically chemical composition. Mechanical properties mean they can be changed by force. For example, what are the physical properties? Density, conductivity, permeability, specific gravity. These all are considered as a physical properties for an inspector because it is basically a welding inspector course. I think you may be knowing 577, there is separate certification in API. 577, there is separate certification is there. 571, there is separate certification is there. These are called supplementary exams. Okay. Now coming back to the physical properties, as a welding inspector, the important is conductivity. Conductivity, heat conductivity. Now the question is, a high conductivity material, easy to weld or difficult to weld? High conductivity material, easy to weld or difficult to weld? The answer is difficult to weld. Example is copper. Copper is a very good conductivity, but the problem is it will not hold the heat. It will pass on the heat, so it will not melt easily. That's why copper generally they will go for brazing. Compared to steel, copper is a high conductivity. Steel is a poor conductor. That's why we are making this welding. Opposite, a low conductivity material, you should not weld continuously. Otherwise, there will be a distortion problem. For example, if you take stainless steel, carbon steel, stainless steel conductivity is 30% less than carbon steel. That's why if you take stainless steel, any procedure, interpass temperature will be specified. Maximum interpass temperature. They will say, you should not weld continuously stainless steel, otherwise it will start bending. You should give each and every pass cold sometime. Let it cool, then you have to start it. ரொம்ப கஷ்டமா இருக்கா மெட்டலர்ஜி? இல்லை ரொம்ப சிம்பிளா தான் போறேன், ஒன்றும் ரொம்ப டீப்பாலாம் போகல. ஓகே, சொல்லுங்க. வெல்ட் அடிக்கலாம், வெல்ட் அடிக்கலாம். நம்ம எவ்வளவோ அதை ட்ரை பண்ணி பார்த்தா அளவுக்கு இல்லை, அது அடிக்கணும். நான் வேணா என்கிட்ட ப்ரொசீஜர் இருக்கு தரேன். வேற ஏதாவது இல்லை, பர்ஜிங் வச்சு அடிக்கணும். வெல்ட்ரு சரி அடிக்கலாம், கொப்பனைகள் நாங்கள் அடிச்சிருக்கோம் ஆல்ரெடி. ஓகே, ரைட். கமிங் பேக் டு தட் physical property. Chemical properties, chemical composition. What is the maximum carbon percentage allowed in the welded construction? As per section 8 and 510, 0.35. 510 have another requirement. Above 0.3, preheating is mandated. That is carbon. There is one thing called carbon equivalent. What is carbon equivalent? The word is theoretical carbon content is called carbon equivalent. Okay. This is one of the exam question. Carbon equivalent measures. Answer is theoretical carbon content. There is a formula. Percentage of carbon plus chromium plus molybdenum divided by 5 All the formula no need to remember, but you should remember this value. When carbon equivalent less than 0.35, no precaution required. Without preheating, you can weld. Carbon equivalent less than 0.35. Carbon equivalent 0.35 to 0.55, preheating is mandatory. When carbon equivalent more than 0.55, preheating and PWC is mandatory. Carbon equivalent is different, carbon is different. Carbon more than 0.35, welding itself not allowed. That's all chemical property. Now coming to the mechanical properties, you should know 5 properties. Tensile strength, ductility, hardness, hardenability, toughness. Okay, these 5 mechanical properties you should know. First, what is yield strength and what is tensile strength? I already told what is yield strength, at which load material changes from plastic to elastic. Okay, that is called yield strength. Tensile strength means the maximum load a metal can withstand. Above this, it will break. Now, coming back to tensile strength. When you receive the material, the tensile strength is given by the material manufacturer. For example, SA 5 ounces is grade 70. So the minimum tensile strength will be 70 KSI. When you purchase the electrode manufacturer will give the test certificates. Now we are bringing material and we are bringing electrode and we are going to make a weld. Before start any fabrication, we have to qualify the procedure. So how we will qualify the procedure? We will make a weld. Okay, that weld is called a weldment. That tensile test we have to do it. For example, if you are qualifying a plate, for example, this is your plate weld. For tensile test, so this is your weld. As per section 9, we have to cut 2 test coupons. These are called transverse test coupons. Okay, because a transverse test coupon involves base metal, heat effect zone, as well as weld metal. Now, if you have a pipe weld, for example, this is your pipe weld. Again, 2 test coupons. One should be cut at the top, another one should be cut at the bottom. If you take circle shape, this is your weld. So one specimen here, one specimen here. 2 tensile is mandatory for procedure qualification. These are very important for exam. Now, tensile specimens, after cutting, you can prepare 3 types of specimens. Reduced tensile specimens, turned specimen, turned means round shape specimen, and full diameter specimen. Full diameter means if the diameter is 3 inch, less than 3 inch, we can use a full pipe. For our exam, the exam question will be generally based on reduced tensile specimen. So what is meant by reduced tensile specimen? Suppose this is your specimen. We will reduce at the center like this. So this is your weld. Now question number 1, why we are reducing? Why we are reducing at the center? So that the failure will happen at the weld. Because if you take a straight specimen, generally the electrode strength, we are using the higher strength electrode. So when you pull it, it will always break in the base strength. So you cannot find what is the tensile of the pillar metal. So that's why we are reducing. Another one, this is the weld. We will flush grind the weld. Why we are flush grinding weld? To calculate the area accurately. So what is the formula for area? This is your width and this is thickness. You will measure from here only, the weld area. So area formula is width multiplied by thickness. Width multiplied by thickness. Now, width also we are measuring in inch. Thickness also we are measuring in inch. So we will get answer in square inch. So once you calculate the area, then we will pull it and break. For example, if you see here, So this is how the tensile test. So they will pull it to break that one. Now you see where it is going to break. Top, bottom, or middle. You can see here. This is the necking. You can see here. The dimension is changing here. Okay. So now it's broken. Now we will measure the load will be shown on the machine. So how to calculate the tensile strength? So the tensile strength formula is equal to load by area. So load will be shown in pounds. Area in square inch, already we measured. So we will get the answer PSI. Now the next one is, what is the acceptance criteria as per ASME section 9? This understanding is very important. It is open book question only. For example, your material is say SCA 516 grade 60. And you are using electrode E7018. So what is the then base metal tensile strength? 60. No. So grade 70. Yeah. I will put it 60. Okay. So base metal tensile strength 60. Electrode tensile strength 70. This is one of the possibilities. Or all can be 70. Suppose you are using the material 70. Then all are 70. Sometimes it can be like this also. One is 60, another one is 70. Dissimilar. Or, so 510 we have seen 70, 70, 60. Lower filler metal also allowed 510 this one. These are the various possible combinations. Now the question is, what is the acceptance criteria as per section 9? We have to check where it breaks. If it breaks in weld, so the first rule, if break in weld, so your calculated tensile strength should be greater than or equal to minimum value of BM means base metal or WM means weld metal. So what is the minimum value here? 60, the total minimum value. So it should fall if it is 60,000 PSI. Again, I will repeat, if it breaks in weld, which is the lowest value, whether it is a base metal or filler metal, whatever it may be, lowest value it should make. Now the next one, if it is break in the base metal, break in base metal, the calculated tensile strength should be greater than or equal to 0.95 or 95% of base metal value. So a 5% reduction is allowed. Which side it breaks? For example, this side it breaks 60 of 95% of 60,000. Suppose this side it breaks, for example, here 70 side it breaks 95% of 70,000. Again, I will repeat. If it breaks in weld metal, we have two base metal, one weld metal. We have three values, two base metal, one weld metal. The lowest value it should achieve. If it is break in base metal, that side 95% it should achieve. Okay. Another one is, I told how many specimen you have to take? 2. There is concession given in the section 9. So for thickness I told what is T is the thickness, less than or equal to 1 inch, 2 full thickness test coupon. Thickness coupon. For thickness greater than 1 inch, you can go 2 full thickness coupon or multiple equal thickness coupon. See, what is mean by multiple equal thickness coupon? Suppose your thickness is say 3 inch and your machine does not have that much capacity. You can cut the 3 inch into 3 1 inch. Then we will get how many specimens? 3 plus 3, 6. All the 6 should pass the test. Then only the test is considered acceptable. Even out of 6, 1 fails, the test is failed. This is, you should know about the tensile test. Is it clear? Please write this.
Yeah, they will.
Recording from this. Okay. Yeah, please write, please write. So again, I will repeat. This you see, tomorrow we will see section 9. There will be a WPS PQ review. Generally, there will be 2 questions in the exam. Sometimes, very rarely, 1 question. Sometimes it can go up to 4 also. Okay, different set they are using. So tomorrow we will do section 9, how to prepare a PQR, how to qualify a PQR, then how to write a WPS. This all we will see tomorrow. So for that, this all the basic mechanical testing. These are the section 9 requirements. Section 9 mechanical testing only 2. Tensile test and bend test. Bend test, only 2 are the considered in the section 9. Even though we are going to cover now, I told the tensile means tensile strength, ductility, hardness, hardenability, and toughness. Completed. Next one is ductility. See, what is the definition of ductility? Ability to deform plastically. Plastic means permanently, without fracturing. If you pull, if it is not break, that is ductile. Or if you bend it, if it is not break, that is ductile. Ability to deform plastically. Plastic means permanent deformation. Without fracturing is called as a ductility. Now, actually tensile test also we can measure ductility. But for section 9, we will go for a bend test. We have 3 types of bend test. Root bend, face bend, side bend. For example, this is your belt and this is, what is this top side is called face, bottom side is called root. If you are bending like this is called root bend. Opposite. If you are bending like this is called face bend. If you are bending like this is called side bend. Opposite. If you are bending like this is called face bend. Opposite. If you are bending like this is called root bend. Opposite. If you are bending like this is called side bend. Opposite. If you are bending like this is called root bend. Opposite. If you are bending like this is called face bend. Opposite. If you are bending like this is called side bend. Opposite. If you are bending like this is called root bend. Opposite. If you are bending like this is called face bend. Opposite. If you are bending like this is called side bend. Opposite. If you are bending like this is called root bend. Opposite. If you are bending like this is called side bend. Opposite. If you are bending like this is called face bend. Opposite. If you are bending like this is called side bend. Opposite. If you are bending like this is called root bend. Opposite. If you are bending like this is called side bend. Oppos if you are bending like this, phase bend, why I am putting here plus? It is always one root plus one phase or two root two plus two phase. They will come together. Or side bend will be, suppose this is same. If you are bending like this is called a side bend. Side bend will never mix up with the root and phase bends. Purposely, they will give in the exam two root bend plus two side bends. It is not allowed. Always you should remember one root means always plus one phase or two side bend. Two root means two root plus two phase always or four side bends. Either root plus phase or side bends. Is it clear? Now, which bend is required? Procedure qualification also, the bend test is mandatory. Welder also we can qualify using a bend test. Okay. For example, it depends on the thickness. For thickness less than 10 mm, so 10 millimeter in the code language is 3 by 8 inch. For PQR, we have to do only two root bend plus two phase bend. No need to remember all these things. This all open book only. You should know how to refer it. Suppose if you are qualifying a welder, we call it as a WPQ. When qualifying welder 5G or 6G positions, say two root bend plus two phase bend. Other positions, one root bend plus one phase bend. Now, first, what are the positions we have? If you take plate, if the plate is like this, welder is welding. This is called flat 1G. Plate is horizontal, welder is welding. Horizontal 2G. Vertical 3G uphill, 3G downhill. Overhead 4G. So plate have four positions: 1G, 2G, 3G, 4G. 1G is flat, 2G is horizontal, 3G is vertical, 4G is overhead. If you take a pipe, if the welder is welding like that and the pipe is rotated, this is 1G rotated. Pipe is fixed, welder is going around and weld, that is called 5G, and it is called multiple position. Why multiple? When the welder is welding here overhead, here vertical, here flat. Then pipe is like this, weld is welding here, it is horizontal, 2G. This is 2G, this is 5G, 45 degree, we call it as a 6G. Now, it need not be exactly 45, a 5-degree deviation is allowed. This here horizontal and this one 15-degree deviation is allowed. Okay, so if you are qualifying a welder in 5G or 6G, two root bend, two phase bend. If you qualifying other positions, one root bend plus one phase bend when the thickness is less than 10 mm. Suppose the thickness is 10 mm to less than 19 mm. So 19 mm code along with 3 by 4 inch. We have both options. Two root bend plus two phase bend or four side bend. Here also two root bend plus two phase bend or four side bend. Here one root bend plus one phase bend or two side bend. Right. Again, I will repeat, no need to remember these things. These are open book only. Then for thickness 19 mm and above, four side bend, two side bend. So I will put it like this. Less than 10 mm, you can see side bends are not allowed. 19 mm and above, root and phase bends are not allowed. In between, both are allowed. Either it is two root plus two phase or this one. Now, how we will conduct a bend test? So this is the bend test to use. So this is a guided bend test. Now you can see the bend test. What is the acceptance criteria? Any cracks, right? Any cracks here, 3 mm allowed. 3 mm is 1/8 inch. If the crack starts from the corner, we have to check inside crack any defects are there, like a porosity, slag. If nothing is there, 3 mm, any length allowed actually. If there is a porosity or slag like that, only 3 mm allowed. Okay. So right. So acceptance criteria, cracks greater than 3 mm. 3 mm is 1/8 inch, or we can sometimes they put 4/32 inch, not acceptable. Next condition is corner cracks without evidence of imperfection. Any length acceptable. Please write these things. Hmm? A1 for visual test. A2 other entity. Why we are going, this all section 9 requirements, because for procedure qualification and welder qualification, you should know about the tensile test and the bend test. Right. So we have seen, yes. Okay. So tensile strength we have seen. Next one is the ductility. Hardness, hardenability, there is no direct relation. Both are entirely different properties. Many people think hardness and hardenability both are same. They are not same. First difference, definition itself is changed. What is the definition of hardness? Ability to resist indentation by plastic deformation. When you press something, if it is resist, that is called hardness. Ability to resist the indentation by plastic deformation. What is the hardenability definition is depth of hardening by quenching. How much depth it is hardened. So hardness is the surface property. Hardenability is the entire thickness property. Third difference is hardness you can improve by adding carbon. If you want to improve the hardenability, you have to add chromium, molybdenum, vanadium, not carbon. Fourth difference is, what is the hardness test? What are the hardness tests? Brinell, Vickers, Rockwell, one more. There are 4 tests. We said 3. Brinell, Rockwell, and Vickers. Fourth one is called Knoop. Knoop, K-N-O-O-P, Knoop. There are 4 tests. What is the hardenability test? Jomny bar or Jomny end quench test. That is called a hardenability test. You should know these names. These are important. Now, what is the relation between hardness and PWST? You can see sometimes after the PWST chart, they will mention the hardness also. There is a column. See how a hardness is one of the way to confirm whether the PWC is done properly. If PWC is done correctly, hardness value should come down. A high hardness value shows that PWC is not done properly. Okay, that's why. Now, what should be the hardness value? If we have a stress corrosion cracking problem service, we have seen morning, amine stress corrosion cracking, caustic stress corrosion cracking, the maximum hardness allowed for carbon steel is 200 Brinell hardness. Half molybdenum steel is 225 Brinell hardness. Other chromium molybdenum steel is 241. It is open book question. No need to remember it. Finally, toughness. What is the purpose of toughness? To absorb energy when impact load. Ability to absorb energy under impact load. There are 2 types of toughness test. One we already know that, Charpy. What is the other one? What are the 2 types of toughness test? One is the Charpy impact test. We have IZARD test. There are 2 types of tests. Okay. Charpy test already. This is about the mechanical test. Now coming to the heat treatment side. What is the purpose of preheating? To avoid hydrogen cracking. How it avoids hydrogen cracking? By controlling the cooling rate. What is the purpose of PWST? To relieve the residual stress formed during welding. What is the purpose of post-heating? To allow the hydrogen to come out of the weld. We should know this heat treatment. Then what about the stainless steel metallurgy. If you take stainless steel, the problem during welding is one is called sensitization, another one is called hot cracking. How to avoid hot cracking? You should have 5 to 20% ferrite in the filler metal to avoid hot cracking. 20%. Then coming to the hot tapping. So hot tapping is covered in APA 2201. We have seen PCC 2 also. What are the two major problems to hot tapping? Burn through and cracking. Why it is cracking? Because inside there is a flow. To avoid cracking, you have to control the flow rate. Minimum flow rate should be 1.3 foot per second, maximum 4 foot per second. To avoid burn through, you should have a small diameter electrode, 2.3 mm, to control the heat input. 4 foot per second. Okay. And another important, which NDT is mandatory during hot tapping location? Answer is PMI. PMI you should do and confirm the material is correct material. That's all metallurgy. Okay, simple metallurgy and mechanical test. So please take the code book. So we will start from middle actually. So straight away go to the page number 95. Please take page number 95. Right, page number 95. Okay, so highlight this one. Harness testing of the base metal, weld and HST is often required to ensure that the welding process and any PW has resulted in acceptable relative hardness. That is closed book question. So why you are doing hardness test? To ensure that it is acceptable hardness test. Then this one, hardness tests are covered in APA 582. Highlight this one. APA 582 detail hardness test requirements for PQR and production wells. So APA 582, that is closed book question. And these are not important. Please go to the page number 97. Highlight these lines. Welding inspection activities can be separated into 3 primary stages. Welding inspector should perform specific tasks prior to welding, during welding, and upon completion of welding. So we have to do inspection before welding, during welding, and upon completion of welding. That is closed book. And these are not important. Then please go to the page number 105. See, any time if the inspector finds some non-conformance, suppose they are using a wrong electrode, 2 things he has to do. First thing, you have to stop the welding, inform to the senior. Second thing, he should correct, then proceed welding. Okay, it should be corrected before proceeding further, and it should be informed to the senior person. That is only. And the next one, suppose you find a radiography a defect, who is responsible to mark the area for repair? Inspector. Who will approve the repair procedure? Inspector or engineer. Okay, highlight this one. Anytime during the welding, defects are non-conform to the reference code, standard, or specification are identified, they should be brought to the attention of the responsible to the work and corrected before welding proceeds further. Then corrective action for non-conform depend on the nature of the non-conformance and its impact on the properties of the weldment. That is closed book question. Then repair wells. When inspection identifies a rejectable defect, inspector should mark the area for repair. That is open book. Then this is closed book. Repair welding should be performed according to the weld repair procedure accepted by inspector or engineer. That is closed book. Right, metallurgy, please go to the page number 109. This is closed book question. Knowledge of cast structure is important since the welding process is somewhat akin to making a casting at the foundry. The welding process is akin to making a casting at the foundry. That is closed book. The next page, wrought materials, 10.2.3. Highlight this line. The majority of metallic metal used in the fabrication refinery are used in the wrought form rather than the cast form. Then page number 11, what is the heat affected zone? To highlight this three line, for carbon steel, the HZ include those regions heated to greater than 1350 degree Fahrenheit. Each weld pass applied as its own HZ and the overlapping heat affected zone extends through the full thickness of the plate or part welded. That is closed book. Then page number 112, thermal conductivity 10.3.3, highlight this three line. In general, metal with high electrical conductivity also have the high thermal conductivity. Metal with high thermal conductivity require higher heat to weld than those with lower and may require preheat. Then page number 113, tensile strength and yield strength. Highlight this three paragraphs. Tensile testing into the tensile strength, yield strength, elongation, stress and strain definition. Then page number 114, ductility. This is closed book. In tensile testing, ductility is the ability of material to deform plastically without fracturing, measured by elongation or reduction of area. Then same page, this one, hardness and hardenability. The hardness of a metal is defined as resistant to plastic deformation by indentation. Indentation hardness is measured by various tests such as Brinell, Rockwell, Knoop, and Vickers. That is closed book. You should know the methods Brinell, Rockwell, Knoop, and Vickers. Then page number 115, toughness. The first three lines. Toughness is the ability of metal to absorb energy and deform plastically before fracturing. An important metal property to tank and pressure vessel is the fracture toughness, which is defined as the ability to resist fracture or crack propagation under stress. Then preheating. This is important. The primary purpose of preheating carbon and low alloy steel to reduce the tendency for hydrogen individual cracking. Okay, that is important. That is closed book question. The next page, 117, hardening. Hardening or hardenability is defined as the property of ferrous alloy that determine depth and distribution of hardness by quenching. That is closed book. Then this one line, a typical test of hardenability is called a Jominy end quench test. Jominy end quench test. Then highlight this one. It may be important for the designer, welding engineer, and inspector to understand the hardenability of the steel, as it can be indirect indicator of weldability. So when the hardenability increases, weldability will come down. Then this is asked in the extended matching in open book. What should be the hardness value? Highlight this three line. Hardness in excess of those listed can result in stress corrosion cracking in service due to presence of sulfides in the process. Okay, so you can see here, carbon steel 200, wherever half molybdenum come 225, other chromium molybdenum 241. Then highlight this one, PWST. The primary reason, same page. Post-hole heat treatment relieve resources welded fabrication. PWST also conduct to reduce the hardness of the sets. Stresses occur during welding due to localized heating and temperature changes may occur. That is closed book question. Then material test reports. Next page. The last three lines. The product analysis is the more useful to the inspector and engineer because it provides the more reliable identification of the actual material being used for new fabrication or repair of existing equipment. Then page number 120, last is the pair of this one. The carbon equivalent calculation establish the theoretical carbon content of metal. That is open book question. Theoretical carbon content is the keyword. And considers not only carbon but also the effect of other alloying elements. Then the formula is not important. These values are important. Typically steel with the CE less than 0.35 require no preheat. Steel with the CE 0.35 to 0.5 usually require preheat. And steel with the CE greater than 0.55 require both preheating and PWST. That is closed book. Okay. All right. Then stainless steel 123, page number 123, the second line. The most important consideration to welding austenitic stainless are solidification cracking, hot cracking, distortion, and maintaining corrosion resistance. Highlight that one. And this one, the third paragraph. The most common measure of weldability and successfully hot cracking is the ferrite number of weld metal. And same paragraph, last line, several sources recommended 5 to 20% ferrite content to prevent cracking. That is closed book question. Then page number 124, hot tapping and the in-service welding. Highlight the first three lines. API 2201 provides in-depth review of safety aspects to be considered when hot tapping or welding on in-service piping equipment. Prior to performing this work, a detailed written plan should be developed and re-welded. This is closed book. Two primary concern welding in-service piping are burn through and cracking. That is closed book. Then this paragraph is important. Hot tap and in-service operation should be carried out only with low hydrogen consumables and electrodes. Extra low hydrogen consumables such as EXX should be used for welding carbon steel with a carbon equivalent greater than 0.42%. That is recently asked open book question. Carbon equivalent more than greater than 0.42, you have to use extra low hydrogen electrodes. That is open book. Then flow rates. Highlight this one. An appropriate flow rate should be maintained to dissipate the heat. The minimum flow rate is 1.3 foot per second for liquid and gas. The fourth line, the allowable maximum flow rate 4 foot per second is the upper limit, 1.3 to 4. Then burn through, this is very important. To minimize burn through, the first same page. Okay, close book question. To minimize burn through, the first weld pass equipment piping less than 6 mm should be made with 3 by 32 inch. There is a mistake here. It is not 5 millimeter. 3 by 32 is equal to 2.3 mm. Cut and write 2.3. Or smaller diameter electrode to limit the heat input. Then page number 127. Highlight this one. So inspection, this is the major inspection, performing PMI on the hot tap component. That is open book. Then page number 128. So highlight this one. Prior to welder repairs in caustic service, a corrosion specialist should be review the details of welding plan and ensure suitability of service. That is open book question. That's all metallurgy. So the next part is just we will go another 15 minutes. Welding process.